Hello everyone, let's solve MEXT exam Math B 2007 question 2, okay? So for this question we are going to use some similarity of triangles to prove the first part, which is the easier, not too easy but it is easier, and the second part it needs the minimum volume, so we are going to be using calculus, okay? Derivatives. In the second part it will be derivatives, okay? And I'm going to solve other questions like this from my book, like what if we had not a cone but something like this, okay, and a sphere inside it. So I'm going to be solving questions like this. I'm going to solve I think 2 questions in another video similar. I will leave them both in the playlist of this 2007, okay? So look, when you have these questions like I need to read the question first, sorry. Suppose that a sphere of radius 1 is inscribed in a right circular cone with radius small r and height h. Express r in terms of h. So what is he telling us? Well, we have this cone, okay? Now look, in the cone we are not going to look at it in the space, okay? We are going to take the front look, how someone from the front will see this cone. Someone from the front will see the cone like this, right? He won't see a sphere, he will see just a circle, okay? Someone from front, okay? Yeah, let's try again. This is better. And let me just do this. Here we go. So this is what someone from front will see. Now this radius over here is this radius over here, sorry, this radius over here is small r, right? And this is the value of h, right? And so this is h, and here over here we will have the radius of the sphere, right? So the radius of the sphere is equal to 1. So I'm going to call the radius of the sphere big R. Big R is equal to 1, okay? So big R is equal to 1. How do I know this? Well, he told me this. He said this. Okay, over here. Radius, a sphere of radius 1 is inscribed in the right circle cone, okay? With a radius small r. Why am I going to call it big R? Because I want us to calculate like a value for anyone, because for example it might in the next exam the big R might not be 1, okay? So let's calculate this. So how can we go on when solving this? So look, this is the front, how we'll see it from front, right? Here we go. Okay, so and this is, so this point over here I'm going to call it point O, okay? This point over here is point A. This point over here is point B. This point over here is point C, and this point over here is point D, okay? So this is R, right? So this is R, and this is 90 degrees, right? Because this is a tangent line to this sphere, okay? So this is 90 degrees. This is 90 degrees, okay? This is 90 degrees, and this is alpha. So now we are going to use the similarity of triangles. Look at the triangle AOD, ADO. Look at the triangle ADO. What this one over here? Sorry. This triangle here. 1 second. Here. This triangle over here, okay? So this is the triangle ADO. Okay, I'm going to I'm going to make this triangle again, but over here, like this, look. So remember we had 90 degrees and off. I just took this triangle over here and rotated, okay? Just so that we can visualize it better. So look, in the 90 degrees, we had the point D, right? So this is point D. In alpha, it was point A, okay? In alpha, it was point A, and here it was point O, okay? So this is this triangle over here. And now let's put some value. So the value of DO, what is this value? It is big R, right? Big R from D to O. What about the value from A to O? This value over here, from A to O. How much is this? Well, look, all this is H, right? This part over here, this part over here, this part over here, what is it? This part over here is big R, right? This is R over here, R. So what is this? Well, this is H minus R, okay? So this is H minus R, okay? From A to O is H minus R because all of it is H, and this part over here is big R, okay? So now, and this is, so this is our, this is the triangle on yellow. Now let's look at another triangle, the triangle ABC, okay? ABC. So let's do the same for ABC with red. So the triangle ABC is all this, right? It is all this. You see it? ABC. Here. A, B, C. Okay? So how is this triangle? Well, let's draw it over here. Now this one is easier to draw, right? Because we don't need to rotate it. So A, B, C. Here it was 90 degrees and off. Okay? So this part over here is small r, right? Small r. So this is small r. This part over here, A to B, is H, right? So H. Now what is this value over here? Well, it is, like, let's call it something. Let's call it A. We need to find the value of A, okay? So A squared, Pythagoras, right? Pythagoras. Pythagorean theorem, right? So A squared is equal to R squared plus H squared. So A is equal to the square root of R squared plus H squared, okay? Now, this is our triangle in red, okay? So, why did I do all of this? Because now we have two triangles. And they are similar. Now, this one, I drew it bigger, okay? Bigger than he actually is. You can see it over here. It's very small. And I rotated this one. Now, we need to find... Now, look. We have alpha. We have alpha. We have 90 degrees. We have 90 degrees. So these triangles are similar. How similar? Well, they have proportionality, right? What do I mean? What do I mean by this? That the hypotenuse has a relation with this hypotenuse. What do I mean? Well, the square root of r squared plus h squared, this one, divided by h minus r, h minus big R, must have a proportionality to small r divided by big R. Okay, so I divided this side by this side, and this uh, division must be equal to this side divided by this side. Okay, so just similarities of triangles. Okay, now look, now remember that R is equal to 1, big R is equal to 1, so it's not a problem. Now in the question he's asking us express R in terms of H. So we are on the right track. Why are we on the right track? Because look over here. Look over here. We only have small r and h's. This big R is 1, so it will vanish. So there is no problem. So we only need to solve this, and we will end part 1, okay? So let's solve. So I'm going to take this to the other side multiplying, okay? So R multiplying by H minus R, and this will go to the other side multiplying, so we will have is equal to big R, which is this one over here, multiplying R squared plus H squared. Okay, now look, we have this part over here squared, so in the square root, so let's put everything squared so that we can get rid of it. So this squared and this squared, okay? So we'll have that R squared multiplied by H minus R squared is equal to big R squared and big R squared, and this square root will vanish, right? Multiplied by small r squared plus H squared, okay? So R squared multiplied by H minus, let's solve this part over here, okay? H minus 2H big R plus R squared, right? I just opened this square root, this square power, okay? So now I'm going to put this inside. So we'll have that R squared small multiplied by big R squared plus big R squared multiplied by H squared. Now this part over here will go to the other side subtracting, right? So we will have that R squared multiplied by H minus 2H big R plus R squared minus, and here, wait a second, minus, this goes to the other side, so R squared multiplied by big R squared is equal to this part over here, R squared multiplied by H squared. So look, in any moment we can just put the value 1 in big R, right? I'm just carrying with me so that we can find a general term, okay, for anything that comes out. So look, we have R squared over here and R squared over here, so we can take it outside there. So R squared multiplied by, here is H squared over here, okay? When you open this part squared, this is squared. I just forgot about it. So minus 2HR plus R squared minus R squared, this over here, okay, is equal to R squared H squared. The only thing I did in this step over here was we had R squared minus R squared something minus R squared multiplied by something, right? If you multiplied here again, you will find the same thing that we had, okay? So why did I do this? Well, because now we have the R separate from everything else. Now we can say it in terms. So look, R squared minus R squared will cut, so we'll have that small R squared multiplied by H squared minus 2HR is equal to R squared H squared. So R squared is equal, this will go to the other side dividing, right? So R squared H squared divided by H squared minus 2HR, okay? Now remember, r is equal to 1 and here is equal to 1, right? So let's let's keep it. Yeah, so now let's take the square root in both sides. Okay, so the square root in both sides. Okay, so this is what I'm going to do. So r is equal to big R multiplied by h, taking the square root, we'll end up with this, divided by the square root of h squared minus 2hr. Now remember that big R is equal to 1, so small r is equal to h divided by the square root of h squared minus 2h. Okay, so this is our answer for the first part. We ended up finding these relations between r and h. Look, this was the general relation for any big R, any radius of sphere. So if you want to take a note of it, okay. And this is for our case over here. Now, what is our goal? Well, now our second goal is to find the minimum of the volume of such circular cone. So the volume of a cone is equal to P multiplied by R squared multiplied by H divided by 3. Okay, this is the volume, this is the formula for the volume of a cone. Okay, so now look, if we want maximum and minimums, what we do, we take the first derivative and say it equals to 0. Okay, but how can we take this derivative over here? Because we have r and h that might vary. So what can we do? Well, we know the value of r, so we can put the value of r and then we will have only one variable. Okay, so this is what I'm going to do. V is equal to P multiplied by h divided by 3, and there multiplied by r squared, right? But in place of r squared, I'm going to put this squared. Okay, I'm actually even going to just copy it. Okay, so copy it over here, and it is squared, right? Because r is squared. So we'll have that v is equal to, remember we didn't derive yet, so now multiplied by h squared divided by, because this is h squared, okay, and here we have the square root squared, so the square root will vanish, right? Vanish, no, but this is not the word, but so 2h. Now look, v is equal to p multiplied by h divided by 3 multiplied by h squared, and here we'll do h multiplied by h minus 2, right? Because if you multiply h inside, you will go back here, so we didn't change anything. Why did I do this? To cut this h with this h over here. Okay, so we have that the volume is equal to ph squared, okay, divided by 3h minus 2, okay, this over here. But let us put the 3 inside. Okay, so 3 multiplied by h, 3h minus 3 multiplied by 2, 6. Okay, now just so that it can be ready for me to derive, so v is equal to p h squared multiplied by 1 divided by 3h minus 6. Okay, so if you remember, there is a formula for the derivative of a cosine when we have things dividing, right? But if you don't remember it and you remember the derivative of multiplication, there is no problem. Okay, they come from the same origin. So before we derive, let's put v is equal to ph squared, and then this part over here, I'll say it is multiplying 3h minus 6 to the minus 1. Okay, because I remember the formula for, look, if you have a derivative, just here for us to review, if you are deriving, let's say a is equal to u multiplied by v, okay, not this v over here, okay, v, just so a comma, the derivative of a comma will be u comma multiplied by v plus v comma multiplied by u. Do you remember this? The formula for multiplication. Okay, so and when we have a division, I don't remember it well, so I won't try to confuse you, but because I always do it with the multiplication. Okay, so look, let's write it with orange, so that v comma is going to be equal to, so wait, let me use a lot of colors so that we can look. V comma is going to be equal to the derivative. Now when we are, this is going to be the green and this is going to be the orange, okay, this one, okay, so the derivative of the green will be 2hp, okay, and then multiplied by the second one, just multiplied, so we won't have any color, so just multiplied by 3h minus 6 minus 1, and then we will have plus the derivative of the second part. Let me just 1 second over here. Yes, here. So the derivative of the second part is in orange. So the derivative of the orange part, how can we derive 3h minus 6 to the minus 1? What is this derivative? Well, it will be minus 1 multiplied by 3h minus 6 to the minus 2 multiplied to the derivative of the inside, right? 3. If you didn't understand this part, what did I do over here? Look, if you have let's say you have x plus 1, actually 2x plus 1, 2x squared. What is the derivative of this over here? It will be 2 multiplied by 2x and then multiplied to the derivative of this inside. The derivative of just 2x is equal to 2. What are we essentially doing? We are saying that 2x is equal to u, right? So we are saying that u squared. So what is the derivative of u squared? Is 2u multiplied by u comma. But what is u comma? Well, u comma is 2. So 2 multiplied by what is u? 2x multiplied by u comma, which is u comma is 2, right? So this would be our answer. Now, what about our example, our question? Well, for our question, what we have is 3h to the minus 6 to the minus 1, so we can call this u, right? So 3h minus 6 is equal to u. U comma is equal to 3, right? So what is the derivative of u to the minus 1? Well, it is minus 1 multiplied by u to the minus 2 multiplied by u comma. So it is minus 1 multiplied by u to the minus 2. U is 3, h minus 6 to the minus 2 multiplied by u comma, which is 3. Okay, so this is what I'm trying to tell you. Okay, so So we will have it minus 1 multiplied by 3h minus 6 to the minus 2 multiplied by 3, okay, and don't forget the part that is not a derivative, the part that is multiplying ph squared, right? So ph squared. From where does this ph squared comes? Well, from the formula when we have a multiplied by u v and we want the derivative of a comma, it will be u comma multiplied by v plus v comma multiplied by u, right? So this was this v comma and this is u, okay? So now that we did derive, let's just make our derivative prettier so that we can look. Remember, our goal is to say that v comma is equal to 0, okay? So 2h p, which is this part over here, divided by, this is to the minus 1, so it is down, right? So 3h minus 6 plus multiplied by minus, so minus 3, this 3 over here, ph squared divided by 3h minus 6 squared, okay, because here it is minus 1, so it will go down dividing, okay, and this ph squared is over here. So look, now we have here 3h minus 6 squared and here 3h minus 6, so we will need to do the minimum multiple, the minimum common multiple. So we will have the 2h p multiplied by 3h minus 6. You will understand why I'm doing this. 3h minus 6 squared. Look, we can cut the square any moment, right? We can do this. Why did I put this here and here squared? So that we can have them all in the same base, right? So 3p h squared divided by 3h minus 6 squared. So v line is equal to, so now they are all in the same base, so we can just join them, right? So 2hp multiplied by 3h is 6h squared, right? 6h squared p minus 2hp multiplied by minus 6 is minus 12 hp, okay? Remember, so minus 3p h squared divided by 3h minus 6 squared, right? Okay. So 6h squared p minus 3h squared p, we'll have that v line is equal to 3h squared p minus 12 hp divided by 3h minus 6 squared. So now we are going to say that v line is equal to 0 because we want maximum and minimums, okay? So if this let's take it over here, equals 0, okay? So equals 0. So this will go to the other side multiplying and it will 0 up, and it is squared over here, so we just need it so that the h is different than 2, okay? H is different than 2, so it doesn't, so we don't have it 0 down here, but there won't be any problem. So 3h squared p minus 12hp is equal to 0. So we will have that 3h squared p is equal to, this will go to the other side, positive 12hp, okay? So p divided by p will cut, so, and 3 divided by 12, so we will have that h squared is equal to 4h. Now look, let's just join them together here. H squared minus 4h must be equal to 0. So h minus 4 is equal to 0. Why did I do this? Look, h multiplied by h is h squared minus 4h. So there is no problem in doing this, okay? You go back over here. So we either have h is equal to 0, so that can 0 up if h was 0. If this was 0, then 0 multiplied by any number is 0, okay? Or h is equal to 4. Why? Because 4 minus 4 is 0, right? So this would be 0 multiplied by any other number, 0, right? So these are all possible. So our answer is going to be h equals to 4, because we need to have a height. 0 is not suitable. We wouldn't have anything. So remember, where was our formula for the volume? Look over here. Here we had the formula for the volume in terms of h, right? And this satisfies the condition for the minimum h, for the h that give us the minimum volume. So we just plug it in here to find the minimum volume, okay? So v is equal to p multiplied by h squared is 16, 3 multiplied by 4 is 12, minus 6 is 6. So we'll have that v is equal to 16p. 12 minus 6 is 6, so v is equal to 8p divided by 6. So this is our answer. So here we have our cone and our sphere. You can see over here. This was the front view that, one second. This was the front view that we were using to calculate. Here you can see that the h is equal to 4. The radius of this sphere, the diameter of the sphere inside is 2 the diameter. You can see that it goes from 0 to 2, so the radius is 1. And if you are wondering about the radius of the cone, remember the first equation that we found from doing similarities of triangles. We had r in terms, small r in terms of h, right? Small r in terms of h, so you can put the value of h is 4, and you will find this. And remember, why did we derive? We derived to find minimums or maximums. In our case, it was a minimum value of the cone, okay? So we derived to find the minimum value of the cone. We put an equality to 0. We used really lots of derivative formulas, and this is it, I think.